the next thing we're going to talk about is list comprehensions. And list comprehensions, I think, are one of the coolest things you can do in Python because it's a really, really nice way to define lists on the fly. So what does that mean? Well, let's look at some examples. So let's say I have a list of integers. Okay, I'm going to call it integers. And I want to, so I'm just going to define the integers up to 9. Alright, and so here are my integers. And now what I want to do is, let's say I want to square this entire list. I could iterate through it and square each of the elements and add them to a list, but that seems very, very complicated. So what I'm going to do instead is I can use a list comprehension, and I can define the squares as the following. I can make a temporary variable I, and then say for every I in my integers list, I want to do the following. I want to square it. And how do I square it? I do take I times I. And then what's my squares? I get the following. So this is how this works. Now, as another example of this in a text editor, just so we get a different feel for this, let's say I want to create something that makes a divide filter. Okay? And what this does is it takes a list, and I want to filter every element that is not divisible. So I want to basically filter out elements that are divisible. Divisible by a particular number we given. So what is that number? Well, it's just going to be n. Okay, and so what I want to do, how do I do this? Well, we can use the list comprehension again. And so what we can do is we can return every single k for every k in my list. If it's the case that this k divides n equally. And what does that mean? The modulus of n is 0. So let's just test this out to make sure it works. So if I divide, so let me define my integers again, and then if I divide filter on my integers, and let's say I want to filter out everything that divides by 3, I just pass in 3, and I get the following, 3, 6, 9, which are all the integers that divide 3. So this is an example of how we can use a filter operation with list comprehensions. And although you might not see the use of this right now, we will use this tremendously in this course. So make sure you understand how list comprehensions work. And the way it actually, so here are some more examples. So here I have a filter of everything that's even. So I get out all the even numbers out of the list. Here I have a filter for everything that's odd. Again, we have the integers and squares example for 6 integers this time. So that's how all this works. Now, the execution rules for list comprehensions is that we have a long version and a short version. The long version is where we include the filter expression, and the short version is when we don't have any filtering expression. The first thing we do is we evaluate the iterable expression. And what's our iterable expression? It has to evaluate to an iterable value, which is a sequence, in our case so far. And for every element in the order that it appears in the list, we bind the element to the name, and then we evaluate the filter expression. If the filter expression exists, of course, and it evaluates to true, we evaluate the map expression. So the map expression then maps its value over every element in the list, and then every evaluated value we have is collected into a list, and that's our new list. So this is the execution rules for list comprehensions. But if you don't want to remember this, it's actually quite intuitive how list comprehensions work once you get the idea and do a lot of practice. So don't worry too much about this. Now, the last thing I want to talk about is another list processing operation, list slicing. And the motivating question of this is, what if I want to create a list from a part of another list? How do I do that? Well, I have this special syntax with colons, basically. And what my A is, it's a start index. Where do I want to start my slice from? And my end index is where I want to end my slice. And the start index is inclusive. You include the start index, but you don't include the end index. And then your C is like, what are the step size of my slice? And there are also some default values. So for example, none of these have to be included. But if you include some others, but don't include others, they have these default values, and I'll talk about that. And I think the best way to demonstrate that is to just go through some examples. So let's say I have my integers, and I want to get the first 4 integers. Well, to get the first 4 integers, I can do the following. 0, I can go from the first index all the way up to the 4th index. I don't want to include the 4th index, but that works perfectly because the index is exclusive, as we remember. And then, what is my step size? I want to have a step size of 1. And, oh, it's not list, my bad. So, I can't say list, it's integers. So, I get the first 4 integers. Now, in reality, I don't even need the step size because it's the default value of step size. I don't even need this first element because in reality it already has a default value of 0, so I can just do this. So a quick way to get like the first n elements of a list is to just do colon n. So if I want to get the first 8 elements of a list, of this list, I could just do 8 and I'll get all the way 1, 2, 3, 4, 5, 6, 7, 8. So that's a good way to do that. Now let's say I want to get the last few elements of a list. So here I want to get the last I don't know, the last 8 elements of a list. So so basically that just means I don't include the first element. So I don't include 0, so I start at 1, and I go all the way to the end of the list. How long is this list? 9. And then my step size is of course 1. And then I get the following. So if I want to get up to the 4th, everything but the first 3 elements, I just start at 4 and get 5, 6, 7, 8. So actually, I have to include 3 in this example. My bad, because it starts at the 3rd index, which is the 4th element. So yeah. So something you'll find, I just made one right there, but something you'll find common when you're working with lists is you might make a lot of off by 1 errors, because it is a little weird that you start from the 0th index and go to the n minus 1th index. So just be careful of that. Now, actually, if I want to get everything starting from the 3rd index, I can actually I don't even need to include these because they have a default value of the ones that I want. So B has a default value of the length of the list. The length of this list is 9, so I don't need to include that. And the step size has a default value of 1, so I can just do this and get the same thing. So this is good stuff to know. And let's say I want to get every other element of the list starting from the 0th. Well, I can just do 0 to the end, and then step size of 2. And I get 1, 3, 5, 7. So let's say I want to start at the first element and get every other. I get this. So this is how all this works together. And also, one cool thing to know is that all these values can actually be negative. I won't be talking about it too much, but let's say I want to reverse the list. A cool way to do that is to just call on integers and basically make my step size -1. What does that mean? Well, basically, instead of stepping from the start of the list, it starts from the end of the list because you give it a -1. And that's how that works. So what this means is that Python lists are basically modular. Alright, so that's all I have for today. So basically what we did is we went through a lot of list operations. And I didn't really talk too much about the tuple, I know, but the tuple is just a very specific case of the list. The tuple doesn't have as many of the operations the list has. And there's also one fundamental difference that I'll talk about in the future. But for now, if you understand, lists are often more used than tuples in my experience. So I think understanding list operations will help you easily understand tuples. So that's all I have for today. Thanks for watching. I'll see you next time.